Hi guys, welcome back. This is Professor Hank, and in this video we're going to talk about two-dimensional arrays, right? Specifically, we're going to go through 7 things related to two-dimensional arrays. First thing we're going to do is we're going to talk about how you declare a two-dimensional array. It can be very similar to how you declare a one-dimensional array. It's just if you have a second dimension, you're going to have a second size declarator, right? So we're going to talk about that. Then we're going to move on and talk about representation. How you can think about these things in the abstract, and how you can access individual elements of these two-dimensional arrays, and what they're for, what you're trying to do with a two-dimensional array. Spoiler alert: tables. Then we're going to talk about initialization, how you can initialize an array with an initialization list. And remember, initialization talking about defining and assigning at the same time, right? So initialization. Then we'll talk about two-dimensional arrays as a parameter or an argument. So basically how you can pass two-dimensional arrays as arguments to functions. Then we'll look at some basic processing operations you can perform. You know, what if you wanted to know what the sum was of all of the elements in the array? What if you wanted to just sum up a particular row in the array rather than the entire array? What if you wanted to sum up just the particular column in the two-dimensional array rather than, you know, the entire array? All right, so let's look at some code and see how we can declare these things, right? So if I wanted to create a one-dimensional array of integers, right, I'd have my data type, I'd have the name of the array, let's call it numbers, and then I'd have a single size declarator, right? So I'll use the named constant for that, and I'll call it size, right? Say, I don't know, 4. Okay, so this is how I would create a one-dimensional array, right? So an array that can hold size, number of values, right? Now, one dimension, one size declarator, okay? Now, if I wanted to create a two-dimensional array, what I'm going to do is I'm going to have a second size declarator, right? So let me change this. I'll call this rows, and I'll call this constant named constant calls for columns, right? So the first size declarator will be rows, and then the second one will be calls, right? So this right here creates a rows by calls 2D array. Okay, so what does a two-dimensional array allow me to do? What's it do for me, right? Well, what it allows us to do, a common example of this, is to represent in memory a table, right? Now, in my code, I created an array called numbers that was 4 by 3. There were 4 rows and 3 columns, right? So you can think of it in the abstract as something that looks like this. I've got my 4 rows, and then in each one of those rows there's 3 columns, right? So I've got myself a nice little 4 by 3 table. Now it's rows by columns, right? And so you're going to have, just like you had 2 size declarators, we're going to end up having 2 subscripts, right? So the first subscript is going to be for the rows, and then the second subscript is going to be for the columns, right? So if I wanted to put 3 inside this table, let's say I want to put this 3 inside of the second row or the third row, right at subscript 2, and the third column at subscript 2. So let's say that I wanted to put 66 there, right? So the way that would look is I would say numbers, and then the first subscript would be for the row, and then the second subscript would be for the column. So I'd say numbers 2 of 2 is equal to 66, and so that'll put 66 in the correct cell, or the correct location, the correct element within the two-dimensional array, right? And so similarly, if I wanted to put something, you know, like maybe 99 in the first row, second column, I would do something similar. I would have a statement that looked like numbers, first subscript is the row, second subscript is the columns, and then I'd have my value that I want to assign there, right? So you can see that first row, first column is 0, 0. First row, second column is 0, 1. First row, third column, 0, 2, you know, etc. Okay, for all of the different elements of the array, of the two-dimensional array, right? So this is kind of how it plays out. This is how it looks, right? So each one of these cells is going to require two subscripts, right? First one is for rows, second one is for columns. Okay, so let's see those statements in code, right? So numbers of 2, 2, right? That's going to equal, I don't know, 66, right? And then numbers of 0, 0, 1. We'll make that equal to 99, right? And so then I can send both of those things to cout, just like any other array, right? I just have to specify, you know, which row, which column I want to put those numbers and where I want to retrieve them from. So, so 0 and 1 for the second one. Right, so let's go ahead and compile it and run it. Okay. So, you're going to see the 66 and the 99 right there. So I assigned 66 to that third row, third column, and to that first row, second column. Then I just retrieved them, right? Just retrieved them. Just like one-dimensional array, it's just we've got another subscript, right? And let me show you another thing here, right? Remember, maybe you remember the printed function from the previous video that I did. So we'll bring that back, and you can pass elements of a two-dimensional array as an argument to a function, you know, just like you can for any other type of array. So, you know, if I call printed here and I pass numbers to 2, it's the actual integer inside that element that's getting copied into A, and then that's what printed's going to display on the screen, right? So you're going to see that 66 again, right? So you can pass individual elements of the array as arguments. Okay, so let's look at another example here. Let's say we wanted to write a program that was going to count the total number of steps somebody took over 2 weeks, right? It's a fitness thing. People like to do the number of steps. They like to try to hit 10,000 steps a day or whatever. Something I like to do, kind of a popular thing. And so we want to write a program that's going to tell the user how many steps they walked over 2 weeks, right? So let's go ahead and create an array, okay, that we'll call steps, okay? And since it's going to be 2 weeks, right, then the first row will be how many weeks that we're going to be talking about. There's 2. And then the second subscript, you know, the first subscript is the number of rows for each week, right? There's 2 rows, 1 for each week. And then the second subscript is 7. That's going to be how many columns you have per row. Oops, sorry. Per row representing each day, right? So maybe if I was to use named constants here, I'd say constant weeks equals 2, and then, you know, days equals 7, right? That would be better. So we'll put weeks in here, and we'll put days in here, right? So now if I want to ask the user, you know, how many steps they did for all of the days, I'm going to need a couple of loops, right? I'm going to need, since I have 2 dimensions, I'm going to need 2 loops, right? When you were traversing over a one-dimensional array, there was 1 dimension, there was 1 size decorator, there was 1 loop, right? But it can be useful to think of this as an array of arrays, right? Where the rows represents the array of arrays and each element itself is an array. So you can kind of think of it that way. But what I need to do is I need to traverse over every single row. So I'll go ahead and create an outer loop, which I'll initialize to 0, and so long as I is less than weeks, right, I plus plus, this is for traversing each row, okay? And then I'll have an inner loop, which I'll do for int j equals 0, j less than days, j plus plus. And then this is going to be for traversing each column, right? So for each row, I have to go and process each column in that row, right? So nested loop is what I need for this. So what I'm going to have to do here is I'm going to have to ask the user, I'm going to have to say, all right, well, enter your steps for that day, right? And so then I'll just read straight into my steps array, right? The ith row, and then the jth column, right? So when I is 0, we're going to be adding steps to the first row, right? And then when j is 0, we're adding to the first column, okay? So we're going to have nested loop for that. And once I've got all of those numbers entered, then I'll need to, right, so we'll enter the total steps for 2 weeks, right? So for each week, there are 7 days we have to enter in steps for, right? So once I've done that, I'll total up all the steps for all the days, right? So I'll do a similar thing where I need an accumulator here. Let's see here, we'll call it total steps, right? And so for int I equals 0, we'll do a similar kind of a structure here, I less than weeks. So for each week, that's what this is all about, right? So for each week, we then have to go through and process each day in that week. Right, j plus plus, and for each day in that week, what are we going to do? Well, what we're going to do is we're just going to take the steps for that particular day, right, and we're going to add that to our total steps. Okay, so total steps plus equals steps. Okay, and then after that's over, we'll tell them. We'll say your total steps for 2 weeks was total steps. Okay, so let's go ahead and let me zoom out a little bit here so you can see the code. I'll give you a second to take a look at that. And then we'll go ahead and run it. Right? So I'm going to have to enter in 14 total numbers. Right? So first day, 9950 steps. The next day, 1200 or 12,100. The next day, 8732. The next day, 6565. The day after that, 13,700. The day after that, 10,050. The day after that, 1, 2, 3, 4, 5, 6, 7. The day after that would be, I don't know, I had a bad day, 1,255. So you see these first 7 numbers, this is all of the inner loop, right? That's all of this inner loop right here executing. Enter your steps for that day, right? So all 7 repetitions happened, and that is for the first repetition of the outer loop. Okay, so continue on. So that just ended, right? These 7 repetitions right here were a result of the inner loop, and then once that inner loop was done, now we're starting the second repetition of the outer loop. Okay, so continue on. 8686. Let's see here. 12, 310, 7,569. 9973. Right now I'm in the inner loop for the second repetition of the outer loop. 11,112. Let's see here, what else? 88, 572, right? So once that was done, once I entered in all those steps, then we went on to the next set of nested loops, which for each week counted up all of the steps in for every single day for that week, and then moved on to the next week, right? So I'll trace through this for you here in just a second. But we've got 14 entries because the first 7 are the result of the inner loop for the first repetition of this outer loop, and then the next 7 are the result of all 7 repetitions of the inner loop for the second repetition of the outer loop, and then the second set of nested loops just added everything up, and then we displayed the result, right? The total of that, 128,462 steps. Okay, so let's step through or trace through, hand trace through a simplified version of that, right? So let's say that instead of 7 days each week, we only walked for 3 days each week, okay? So that outer for loop, right, or the first set of nested loops, or was it looks something like this: for int I equals 0, I less than weeks, and then I plus plus, right? And then there was the inner loop for int j equals 0, j less than days, j plus plus, okay? And then in here, what we did is we asked the user, give us the total number of steps, and then we read it into, or their response, into our steps array, I of j, okay? So that's what that first set of for loops look like, right? So my simplified example, weeks is still 2, but days is 3, just so this won't take forever to go through it, so we can go faster, right? So when the program first starts up, what's in this array? I have no freaking idea, right? Garbage values, we don't know. Okay, we won't know until we actually assign something to the individual elements, right? So once we hit this nested for loop, here's what happens, okay? For loop happens, the I comes into existence, it's set to 0. Now, if weeks is equal to 2, is 0 less than 2? No. So this is, or excuse me, yes. So this is true. So then we enter the body of that outer for loop, right? And so then inside that body, we just start executing code. Once you're inside the body of a for loop, who cares how you got there? You're just going to start executing the code that's there. So there just happens to be a for loop that's in there, and so that for loop's going to do the same thing, right? The j is going to come into existence, and it's going to be assigned 0, and then is 0 less than days? Well, in this case, days is 3, right? And rows is equal to 2. So that's true. So we enter the body of the loop, we print on the screen, hey, how many steps? And so then we read into steps of I of j. Well, what's steps of I of j? Well, I is 0, j is 0. So let's say the user typed in 6, right? We'll just keep these numbers short so I can get this done faster, okay? So that 6 would go into steps of 0, 0, fine. Inner loop finishes its repetition, the j plus plus happens, that j becomes 1. Then we go back up to the top of the inner loop, right, because it's not finished yet. Execute or check its test expression, is j less than days? Yes, because 1 is less than 3. So we enter the body of the loop, print out, hey, enter your number of steps. And so see in steps of I, j, steps of 0, 1. So let's say the user types in 2. So 2 goes into that position, into that cell in the table, and then the j plus plus happens, so j becomes 2. And so then we go to the top of the inner for loop. Is j still less than days? Yes, because 2 is less than 3. So we enter the body of that inner loop, ask them how many steps they want. Let's say they type 4. It's going to be read into steps of 0, 2, steps of I of j. So if they typed 4, then the 4 goes in there. Boom. Last thing that happens in that inner for loop is j plus plus, that becomes 3. Go back up to the top of the inner for loop. Check the test expression, is j less than days at this point? No, because 3 is not less than 3. So the inner loop is done. And so since the inner loop is done, the body of the outer for loop is done. So the last thing the outer for loop does is increment its I, becomes 1, and then the outer loop goes back to the top of the loop and tries to go again. What's in I? 1, is that less than weeks? Yes, because weeks is 2. So we're going to have another repetition of the outer loop. So the body of that outer loop starts executing. Well, guess what? It's the inner for loop again. So j gets set back to 0. Is j less than days? Yes, because 0 is less than 3. Prompt the user, and then we ask them what they want to enter for the number of steps. And so let's say this time they say 3. Well, then we're going to read into I of j, steps 1 of 0, the 3. Okay, and then j++ happens. Go to the top of the loop. Is j less than days? Yes, because 1 is less than 3. Enter the body of that inner loop. Give me the number of steps. Let's say they type 7 this time. So 7 is going to be stored in steps of I of j, steps 1 of 1. So the 7 goes right there. And then j++ happens. Go to the top of the loop. Is j less than days? Yes. 2 is less than 3. So then we enter the body loop, ask them, hey, how many steps are you going to give me? And this time they type 1. Okay, so the 1's going to be stored in steps of I of j, steps 1 of 2, 1 of 2. 1 goes there. And then j gets incremented. Last thing that the inner loop does is increment j. So then we go to the top of the inner loop. Is j less than days? No, because 3 is not less than 3. Inner loop's done. That ends the second repetition of the outer for loop. Last thing that the outer for loop has to do is increment I by 1, so that becomes 2. The outer for loop sees if it's going to go again. Is I less than weeks? No, because 2 is not less than 2. The nested loop structure here is finished, and we see that we got 6, 2, 4, 3, 7, and 1 all stored in our array, and it's completely and utterly populated. Okay, so let's then look and see what happened with the second nested loop. Okay, the second nested loop was very similar to the first one, nested for loops, and that second set looked like this: for n I equals 0, I less than weeks, I plus plus, right? And then we had an inner loop for int j equals 0, j less than days, j++, right? And what did that do? That just added to total steps, steps I of j. Okay, so let's go through this really quick. So for n I equals 0, is I less than weeks? Yes. Right? So then we enter the body of that outer loop. The inner loop starts its thing. So j gets set to 0. Awesome. Okay, is j less than days? Yes, 0 is less than 3. So then we enter the body of the loop here, of the inner loop. Now remember, we had before this structure total steps equal to 0, right? So there's another variable over here I need to include, total steps. That was set to 0 before the loop's even started. Okay, so now total steps is equal to steps of I of j. Well, what's I and what's j? 0, 0. So steps of 0, 0. So that should be plus equals, my apologies. So we added to total steps 6. So total steps becomes 6. And then j++ happens. Go to the top of the inner loop. Is j less than days? Yes, because 1 is less than 3. Enter the body of the loop. Total steps plus equals steps I of j. So 0, 1. So 0, 1, that's 2. So that 2 gets added to total steps, that becomes 8. At the end of the inner for loop, j++ happens. Go to the top of the inner loop. Is j less than days? Yes, because 2 is less than 3. Enter the body of the inner loop. Add to total steps, steps I of j, steps 0 of 2, steps 0 of 2, which is 4. So that becomes 12. At the end of the inner loop, j++ happens. Go to the top of the loop, try to see if you have another repetition. Is j less than days? No. So the inner loop's finished with its repetitions. So the outer loop picks up from there. Now the outer loop, last thing it's going to do is do I++, and then try to have another repetition. Is I less than weeks? Yes, because 1 is less than 2. So then we enter the body of that loop, right? Start the next repetition. So the inner loop starts doing its thing. J gets set to 0. Is j less than days? Yes. So then enter the body of the inner loop, total steps. We're going to add to that steps of I and j again. So what's I and j? 1, 0. Let's write in total steps. Steps of 1, 0. What's in 1, 0? 3. So that becomes 15. Right? Then the last thing that the inner loop does is add 1 to j. Inner loop tries to have another repetition. Is j less than days? Yes. 1's less than 3. So enter the body of the inner loop. We're going to add 2 total steps. Steps I of j. So what's I? 1. What's j? 1. So 1, 1 is 7. So we add 7 to that 15, which is 22. Last thing the inner loop does is add 1 to j. The inner loop tries to have another repetition. Is j less than days? Yes, because 2 is less than 3. So then we add 2 total steps, steps of ij. Steps 1, 2, right? ij, 1, 2. So what's 1, 2? 1. So we add 1 to that, 23. What's the last thing the inner loop does? Adds 1 to j. So that becomes 3. Inner loop tries to have another repetition. Can it? No, because j is not less than days. 3 is not less than 3. So the inner loop's finished. The outer loop resumes its repetitions, or its repetition, I should say. What's the last thing that the for loop does? Increments, does its increment step, I++, so that becomes 2. The outer loop checks to see if it's going to have another repetition. It won't. Why? Because I is not less than weeks. I is 2. What's weeks? 2. So that's false. Okay, so what's the total number of steps? 23. All right, next up, let's talk about array initialization. Initialization, I think that's how you spell it. Right, so we can use initialization lists with 2D arrays, right? Now, before I get into that, let's review one-dimensional array initialization list, right? So let's say that you wanted to create an array of integers and you wanted to implicitly size it. You'd create your initialization list, and that would create an array that has 3 elements in it, right? So you'd have 8 in the first element, 6 in the second element, and 7 in the third element, right? So 8 goes in the first, 6 goes in the second, 7 goes in the third, okay? This position for 8 corresponds to the first element. This position for 6 corresponds to the second element. This position for 7 corresponds to the third element, okay? Fine, okay? Now, I mentioned last time you can kind of think of, or previously, sorry, just a few minutes ago, that you know, you can think of a two-dimensional array as an array of arrays, right? So if we add a secondary subscript, right? Now, with two-dimensional arrays, you don't have the option of leaving the second subscript empty, right? You have to specify how many columns your two-dimensional array is going to have. So let's say 3, okay? So what happens is that this is still going to this position is still going to correspond to the first element. If you think of it as an array of arrays, this position would correspond to the first element in that array of arrays. This position would correspond to the second element in the array of arrays. This position would correspond to the third element in the array of arrays. So what do I mean by array of arrays? Well, if it's an array of arrays, in each element of A, right, if you could imagine each element being its own array, then suddenly this would become an initialization list for that first element in the array of arrays. This would become the initialization list of the second element of the array of arrays, and this would become the initialization list for the third element, right? So it's required, you got to specify how many numbers are going to be in each one of these guys, right? But the compiler can tell, just like with a one-dimensional array, by counting how many total positions you have in that initialization list, right? So it'll automatically plug that 3 right in there for you, right? But anyway, so let's go 8, 6, 7. So this right here is the first array in the array of arrays, or this is the first row, Okay, you can think of it that way too. Okay, now this right here becomes the second row, or the second element in an array of arrays. And then this would be the third row, or the third element in the array of arrays, right? So what does this correspond to? Okay. All right, well, you can imagine that this is your first row, okay, and this is your second row, okay, and this is your third row. Okay, now when I'm saying that array of arrays thing, I keep saying that, imagine this is the first element in an array of arrays. Imagine this is the second element of the array of arrays. And imagine that this is the third element of the array of arrays. If you do that, then this becomes the first position in that array of arrays, this becomes the second position, this becomes the third position. Whereas previously, right, this would have been element 0, element 1, and element 2 if this was a one-dimensional array, right? But since it's a two-dimensional array, each element in turn has their own array, right? So, you know, this is element 0, element 1, element 2, 0, 1, 2, 0, 1, 2, right? So you can think of it as, oh, well, that whole first element was itself an array. Well, that whole second element itself was an array. That whole, you know, that third element itself had its own array, right? Now, if that's confusing, you know, you can just always default to, hey, look, this is the first row. Maybe that would have been easier. This is the first row. This is the second row. This is the third row. Okay, and you can implicitly size only the first subscript here, not the second. Right? So you can put the 3 there, or you can leave it out. Okay, so you know, this is row 0, row 1, row 2, and then here's column 0, column 1, column 2. Right? But again, if this is the whole first element, right? If it's an array of arrays, then this would be the first element in the array of arrays. This would be the second element of the array of arrays. This would be the third element within the array of arrays. Okay. All right. So let's go ahead and write a loop to just print out the contents of the whole thing. So I'll say for int r equals 0, r less than 3 because there's 3 rows, r plus plus, and then we'll do for int c equals 0 for columns, c less than 3 because there's 3 columns, and then I'll see out what do I call that, a, right? A of r c, right? And I'll just put a space in between each number. Okay. So you can see there's all the numbers 8, 6, 7, 5, 3, 0, 9, 4, 1. Now, what if I wanted to make that look more like a table, right? Well, what's happening is, let me run that one more time, right? Everything's appearing on one line because I don't have anything to move the cursor to the next line, right? Well, if I want to make it look like a table where, you know, 8, 6, 7's on one line, 5, 3, 0's on the next, 9, 4, 1's on the next, etc., then what I have to do is after I print out a row, I got to move the cursor to the next line, right? So remember this outer loop, this is controlling rows, or is for the rows, right? The inner loop is for the columns. Right? So this right here is printing out each of the columns, and then it's repeating that for each of the rows. Okay, so once I've finished printing out the columns, right, for a row, for row 0, row 1, row 2, move to the next line. Right? Once finished printing out the columns, move to the next line, right? So let's go ahead and run that and see how it changes, right? 867 530 941, because for the first row, print out all the columns and then move the cursor to the next line, right? Start the second repetition for the next row, print out all the columns, move to the next line. For the third row, print out all the columns, move to the next line. It's that simple. All right, so how about passing a two-dimensional array to a function? Okay, so let's go ahead and write a function that will print out the two-dimensional array, right? So let's take what we just looked at, put it in a function. So the function's not going to return anything, it's just going to print out the contents of the array. So I'll make a prototype and I'll make the function header. Okay, so for the prototype, here's what we're going to have. Okay, so we're going to specify, similar to what we did with a one-dimensional array, we're going to have to put the data type of the array, and then the first size declarator, that can be left empty. That first set of brackets can be left empty. But just like with the initialization list, the second, you have to specify how many elements there are there. Okay, there's no way around that. It's a requirement. You have to do it. The compiler needs to know how long those rows are. Okay, so we'll do that, and then I'll add a second parameter for how many rows there's going to be. Okay, so you have to provide this right here. This is optional, but want to provide, well, I suppose I should provide how many rows and how many columns in my function definition. I'll do both of those things. Okay, so let's go ahead and write this thing out. Okay, so here's rows and here's calls. Okay, so rows is the rows parameter is going to control the outer loop. Okay, R++, and then calls is going to control the inner loop. So for int c equals 0, c less than calls, c++, and then we'll go ahead and see out. I gotta name my parameter here, so I'll just name it a. So see out a of rc. Put spaces in between, and then after the row's been printed out, we'll move the cursor to the next line, just like before. Okay, so that'll do it. So when you're passing a two-dimensional array to a function, that's what that parameter is going to look like. And you have to specify in the second set of brackets how long each row is. The first is optional, just like with a one-dimensional array, but for a two-dimensional array, that second dimension has to be specified. How long the row is has to be specified. Okay, so let's go ahead and create another array here. I'll use an initialization list again, and I'll call this one fish. Okay, so how many rows are we going to have? We'll have 2 rows of fish and 3 columns. Okay, well I got to have 3 because that's what my function is going to take, right? So it's only going to work with an array that has 3 columns, right? It's only going to work with a two-dimensional array where each row has 3 columns. All right, so let's go ahead and put our rows in there and put our calls in there, and then we'll make our initialization list. Right? And so that's going to be the first row, and this is going to represent the second row. All right, so maybe I'll do it like this, just so it looks more like a table. Okay, so something like this. There we go. Okay, so for the first, I'll do, say I got 3 columns, right? So 8, 6, 7, and then for the second, 5, So there's row 1 and there's row 2, or the first element in the array of arrays, if you want to think of it that way. And this would be element 1 in the array of arrays. Okay, so you can look at it either way. I mean, if you're thinking table, then this kind of fits that way. But also, if you're thinking array of arrays, it fits that way too. Okay, so I don't want to make it look like that. All right, cool. So let's go ahead and call the function. So we're going to call it, and you're going to pass a two-dimensional array the exact same way that you pass a one-dimensional array, and that is the name of the array only. The name of the array only, right? So just the name of the array only. Say it 3 times, hopefully it'll stick, right? Now my function needs to know how many rows there are, so we'll pass that as an argument. Also needs to know how many columns there are, so we'll pass that as an argument. Put my semicolon, and then we'll go ahead and run and test it. Okay, so there's the contents of your array, your two-dimensional array. So let me zoom out, just so you can stare at the code for a second if you need to. Okay, and then we'll continue on. Okay, so what if we wanted to know, or we wanted to display or figure out what the sums were of each individual row, okay, of each individual row. Now, previously showed you, we added up all the steps. So we added up everything in the two-dimensional array. Okay, what if I wanted to show you row by row what the totals were? I got to do something different, right? And it's kind of related to what I just showed you with the print function, where we moved the cursor at the end after we had displayed everything in for a row. After we had displayed all the columns for a row, we moved the cursor. Well, we're going to do something similar here. What we're going to do is we're going to add up all the numbers for a row. We're going to add up all those columns, show that to you, and then do it again, right? So let me go ahead and create another array here. So cost in rows equals, we'll make a 3 by 3. How about that? Okay, and we'll just call this nums. And everything that I'm doing here, works for other data types too. I'm just using int because it's easy. But don't think you can only do this with integer arrays. Okay, so make another initialization list here, and so this will be row 0, row 1, and row 2, or the first, second, and third elements of my array of arrays. So there's the first element, or first row, the second element, or second row, and then the last one. Okay. All right. So what we want to do next is we want to add some kind of a total, right? So we need some kind of, we're going to have some kind of a accumulator, right, which we'll call total. Okay, and we'll design this from the inside out. Okay, so we know we're going to need that because if you're going to add up a series of numbers, you have to have some place to add it, right, or to store, as you go. And then we know that we're going to be adding to that total, elements of this nums array, right? So we're going to have to add a number from one of the rows and from one of the columns. Okay, fine. Now, I know that I'm going to be adding up all of the columns, right? So I can go here and say point C equals 0, C less than the total number of columns, C++, I know I have to do that. Okay, now once total's been set to 0, this will go through and add up every single column. It'll go through every single column for a particular row and add up all the numbers in that column for that row and add it to total. Okay, so now the question becomes, well, what about my outer loop? Where do I put that? Well, the answer is that it's going to start here. Okay, row less than rows r plus plus, and I need to reset my accumulator for each row, right? So I'm going to get to a particular row, I'm going to reset my accumulator to 0, and then I'm going to add up everything for that row, right? Now once I've added up everything for that row, I'll tell you the total for that row. For row R is total. Okay, and then we'll move to the next line. So this is going to start off at row 0, right? R equals 0. And then we'll set our accumulator to 0, and then we'll add everything for that row to total. And then once that's done, we'll print out total. And then that first row will be done. And then the outer loop will increment, and we'll start the second row. And we'll reset total to 0. Because we don't want to be adding on to the total for the previous row. We got to reset it to 0. So we'll reset it to 0, and then we'll add up all the numbers for that row, tell you what that is for that row, and then we'll move to the next row, right? Lather, rinse, repeat. So let's go ahead and run it and see what happens. Okay. So the total for row 0, right? Added everything up. 8 plus 6 plus 7, 21. So 8 plus 6 plus 7, 21. We displayed that on the screen. That was the end of the first row. Start the second repetition of the outer loop. Total gets reset to 0. Add everything, all the columns for that row to total, and then we tell you what that total is. 8. 5 plus 3 plus 0, 8. That's the end of the second repetition of the outer loop. The third repetition starts, so that way we can start adding up to third row. Total gets set back to 0. We add up all of the columns, all the numbers in all the columns to total, and then we show you what the result is of that. 11. 9 plus 1 plus 1, 11. It's as simple as that. Okay, finally, what about summing up the columns of a two-dimensional array, right? So, previous example, we went row by row, adding all those up. But what if I want to add up all the columns? That would mean that I'd be adding 8, 5, 9, and then I'd add up 6, 3, 1, and then I'd add up 7, 0, 1. Okay, well, the code's going to look very similar. It's just the outer loop is going to be controlling columns, right? And then the inner loop is going to be controlling rows, right? So we're just going to invert it. So it's going to look something like this. For int c equals 0, c less than calls c plus plus, okay? And then my inner loop is going to have a similar kind of thing. We're going to set that accumulator to 0, and then we're going to say for int r equals 0, r less than rows, r plus plus, and then we'll add to total nums of r c, okay? And then once that's all done, we'll tell you what the total is for column C, okay? Is total, okay? So the reason this works, if you can kind of just trace through it in your head, when C is 0, right? C is staying fixed this time, and it's the R that's changing. It's the R that becomes 0, then 1, then 2, right? In the previous example, it was R that was staying fixed for each row, and it was C that was going from 0 to 1 to 2. But now it's C for each column. Add up everything in the row, right? Row by row by row. Okay, so let's go ahead and run it and see what we get. Okay, so the total is for column 0, I should just said the total for column 0 is, but whatever, 22. Does that make sense? Now remember, the outer loop starts, C is 0, right? And so then total gets set to 0, and then the inner loop starts, R is 0. So 0, 0 is 8, that gets added to total, and then R increments by 1, right? So then it becomes add to total 1 of 0, nums 1 of 0. So nums 1 of 0 would be 5, because that's the second row, first column. Okay, and so then that becomes 8 plus 5 is 13. And then the inner loop increments are 1 more. C is staying the same. So for that third repetition of the inner loop, it's adding the total nums 0 of 2, which is, this is the 0th column and the 2th row, right? Remember, counting of indexes starts at 0. So then we add 8 and 5 plus 9. 8 plus 5 plus 9 is 22. And then we display that on the screen. That ends the first repetition of the outer loop. The second repetition starts, and at that point C is 1. So the inner loop, the body, excuse me, of the outer loop starts, and then total gets reset to 0. Then the inner loop is reset to 0. R is reset to 0. So we're adding nums R of C to total, but R is 0 and C is 1 at that point, right? So what gets added to total, right? So first row, second column, which is 6, right? Then R increments by 1, and then we go through and we add to total nums of 1, 1. R is 1, C is still 1. So then we add the second row, second column. So 6 plus 3, 9. Then the R gets incremented again. R becomes 2. C is still 1. It hasn't changed that because we're still on that second repetition of the outer loop, but now we're at the third repetition of the inner loop. So we've got nums of 1, 2. So nums of 1, 2 is, or excuse me, nums of 2, 1. Sorry, nums of 2, 1. So that gives us the third row and the second column. So it's 6 plus 3 plus 1 is 10. Similarly, for the last repetition, for the last column, we're going to get 8 because 7 plus 0 plus 1 is 8. So I encourage you, if I lost you with words, blah 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 blah, words, blah 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 blah, bust out a piece of paper, hand trace, hand trace, hand trace, hand trace. Okay, see what's happening in memory. All right, so let's summarize what we covered. 7 things. Showed you how to declare arrays. I showed you how they're represented in memory and what they're used for. Usually think table, rows and columns. How to initialize them using initialization lists. Talked about a couple different ways you can think about that. Tables, arrays of arrays, whatever works for you. Showed you how to pass a two-dimensional array as an argument to a function. Showed you what it looked like as an argument. Showed you what the parameter looks like for that. Showed you how to sum up all of the elements of an array. Showed you how to do summing row by row, and showed you how to do summing column. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.